Imagine an AI that doesn't just answer questions or generate pictures, but can actually look at the world, understand instructions in plain language, and then use a robot body to act. That's the promise of Vision Language Action Models, or VLA for short. These systems are starting to bridge the gap between software intelligence and physical reality, and they might be the foundation of the first truly useful household robots. Traditional AI systems tend to specialize. Vision models analyze images, language models generate text. Control systems move robots. VLAs merge all three into one architecture. They take visual input from cameras, combine it with natural language commands, and then output motor actions that a robot can perform. In short, see, understand, and do. This is a big shift because it means robots no longer need hand-coded instructions for every single task. Instead, they can generalize, using the same core model to handle cleaning a desk, stacking blocks, or opening a drawer, just by understanding what those actions mean in context. In the past year, we've seen a wave of new VLA models. Helix, released in February 2025, uses a dual system design. One part handles high-level reasoning, the other deals with low-level motor control. This lets humanoid robots balance fine motor skills with broader goals. GR00T N1, unveiled by NVIDIA in March 2025, builds on a similar architecture but trained with a wider set of robotic data, making it adaptable across different robot bodies. Gemini Robotics, announced by DeepMind in June 2025, takes the powerful Gemini multimodal backbone and extends it into the physical world. It's able to follow natural commands like sort these objects by size while coordinating hands and arms. They even released an on-device version that can run locally without cloud connection. And then there's SmolVLA, also launched in June 2025. Unlike the big corporate models, SmolVLA is open source and lightweight. It doesn't need a supercomputer to run, making it ideal for researchers, startups, and even hobbyists experimenting at home. Together, these systems signal a turning point. Instead of robots being rigid and expensive, VLAs might finally make them adaptable, affordable, and scalable. Why is this important? Because a robot that can understand both our words and its surroundings is far more useful than one locked into pre-programmed routines. Think about warehouse automation. Instead of scripting every move, a supervisor could just say, "Organize these packages by destination," and the robots would figure out the rest. In healthcare, assistants could respond naturally to requests like, "Bring me the blue tray from the counter." In households, it could be as simple as, "Pick up the toys in the living room and put them in the box." VLAs reduce the gap between human intention and machine execution. That makes them a critical step toward real, general-purpose robots. But there are challenges. These models require enormous amounts of multimodal training data, images, actions, and language all aligned. Collecting and labeling robot demonstrations at scale is hard. There's also the issue of reliability, making sure a robot interprets commands correctly and doesn't make dangerous mistakes in physical space. Another challenge is efficiency. Running a giant VLA model on a robot's onboard computer isn't always practical, which is why lightweight models like SmolVLA are so important. Looking forward, VLAs could reshape robotics the same way large language models reshaped software. We might see personal assistants that can fold laundry, prepare ingredients, or help elderly people move safely around their homes. In industry, robots could be retrained with nothing more than verbal instructions, cutting deployment costs dramatically. The race is on. Helix, GR00T N1, Gemini Robotics, and SmolVLA are just the first wave. The next few years will determine whether these systems become science fiction curiosities or the backbone of real, everyday machines. What's clear is that the era of robots that can see, talk, and act has begun. And if VLAs deliver on their promise, the boundary between digital intelligence and the physical world may soon disappear.